Hello. In this presentation, I'm going to give you a quick overview of reliability engineering as a discipline. First, I'm going to define reliability engineering. It measures and improves resistance to failure over time. It estimates the expended time of a lifetime of the equipment, and also it predicts the time to failure as a measure of indication of the reliability of the component. So what do the reliability engineers do? Essentially, they study ways to prevent failures, one of the things they do. That is done through robust design and monitoring degradations that occur while that the items are operating. When I'm talking about items, I'm referring to hardware components, human, software, collection of all the things that contribute to complex systems. Reliability engineers also develop and use models to assess the damage and degradation in equipment and aging of equipment also. They predict the time to failure and mean time to failure, mean time between failure. These are the metrics that often is measuring and predicting how much of a mean life is left of the equipment or the mean life that an equipment can provide if it is new. They also assess reliability of complex systems, which is a collection of different components, and finds the reliability of the systems as a function of the reliability of the component. Reliability engineers also develop prognosis and health management of the equipment, whereby they detect through sensors or observations and inspections degradations in those equipment, and then find how much of a time is expended of equipment and how much of a time is left of an equipment. Reliability engineering came out of two different overlapping themes over the time. The first one is the data-driven viewpoint, whereby it relies on the statistical and probabilistic methods to predict these future behavior of equipment based on the past behaviors or observed behaviors or evidences that we have seen of these performances. The second view is the physics view, whereby it tries to actually model these underlying physical phenomena that causes failure, such as fatigue and cracking, wear and corrosion, and then it tries to find a model, which we call it physics of failure model, empirically, and then use it to find the time of failure. Also, new trends focuses on physical laws to find the same kind of a physics-driven models of how long equipments can last. For example, using the thermodynamic entropy as a measure of life. Examples of areas of applications of these would include in design, for instance, assuring reliability, testing, safety assessments of items, and human software machine interfaces, and establishing warranty for new products. Also, it's used in operations such as repair, maintenance risk, assessing obsolescence and timing for obsolescence, and also performing root cause failure analysis. The data-driven view came out of the post-World War II as an initiative because of the large number of electronic failures, especially due to fatigue. It relies on historical data and occurrences and asserts that the past occurrences and evidences of the past would also apply to future, and whereby they develop models that fits the past, extrapolated into future. For that purpose, they define reliability in terms of a probability of the time of failure exceeding a desired lifetime, for instance, a mission time of a given component. So that's the probabilistic nature of the definition. They also find the reliability of the systems as a function of reliability of the individual components by using different methodologies, such as logic-based methodologies. Examples of that would be fault tree analysis or success tree analysis, or using the reliability block diagram, which shows the topology of a system and how the components are tied together. The physics view, on the other hand, finds the underlying physical phenomena that leads to failure, and in doing so, it tries to find a model that can predict and can model the underlying accumulation of damage and the time that it reaches a level of endurance that beyond which the component would fail. Essentially, that endurance is the resistance to damage, or amount of damage that it can resist. Alternatively, the physics view looks at also degradation in the performance of equipment, finding out how the performance declines over time up to a point that a requirement needed for the operation of the component can no longer be maintained or realized. Another approach to this is also applied stresses, where stresses could exceed the strength. This is the traditional, very old notion in the concept of reliability engineering. Significant research is going in both of these teams these days in expanding this and finding the reliability of complex systems and items. Thank you for your attention.